as the target database for migration. Let's continue. With the different Oracle Database Service options available, how does one decide which database service and deployment would be best fit to their requirement? A first look at the available deployment options. There are two options to choose, either in OCI Public Cloud or Cloud at Customer. In case of OCI Public Cloud, you do not have to perform any infrastructure or data center maintenance as you would do in an on-premises data center. You have the benefit of using other integrated services in OCI along with the database service without performing any configuration. This may be database management, monitoring, data integration, or OCI catalog services, etc. Your data is entirely secured with database encryption at rest or in transit. OCI Public Cloud deployment can support your enterprise multi-cloud deployment strategy as well. Speaking about the second deployment option, customer can choose Exadata Cloud at Customer deployment for specific reasons. In this kind of deployment, the entire Exadata DB service infrastructure in OCI will be hosted in customer data center behind their firewall. They prefer this option when they want to gain cloud benefits and at the same time, they wish to have their databases to be closer to their application to avoid network latency. It is also chosen when customer cannot move their applications to public cloud either due to various dependencies and constraints. Due to data sovereignty compliance requirement or corporate policies, customer have to choose this deployment option so that the data resides in their data center. When there is a requirement for a fully managed or co-managed database service with extremely high performance in on-premises, customer would prefer this deployment option. Next, deciding on the database service to use, let's see first with respect to autonomous database service. You would choose one among the various workload types supported in this database service, which is already optimized depending on the type of workload. It's very simple to provision and start working on the database. Most of the capabilities are automated, so it will automatically take care of your management activities that you usually perform on a database. For workloads which cannot tolerate any downtime and have a high demand on performance or seasonal peak loads with unprecedented need for compute and storage, this should be an ideal platform as the demands can be easily met while your database is online. Enterprises that are undergoing a consolidation strategy for all the application databases, they may choose this highly available service for consolidation. From deployment perspective, you may choose autonomous database serverless that are hosted on a shared infrastructure. They allow fast provisioning. You simply have to load the data and start using the database. Or you may choose the autonomous database in dedicated infrastructure or in Exadata Cloud at Customer. This is preferred when you need more administrative control and need to customize on the operational policies like patching and update schedule, availability, provisioning, etc. You may choose the co-managed platform as Oracle Database targets as well. Choose Exadata DB in dedicated infrastructure in OCI Public Cloud or Cloud at Customer. Similar to autonomous database, these services are chosen for applications with higher workload and performance demand. These services allow secure access to cell. You can create Oracle homes with different supported versions and consolidate application databases. Advantages of using these services is that you perform most of the management tasks with pre-configured tools and CLIs. When the workload's size is smaller, you can host in base DB service, take care of the database performance management, and can take advantage of OCI integrated services like database management to monitor and tune performance. You can gain access to shell as root user and install agents or software for which you own the license. Here too, you have to make a call as to when you decide to perform the maintenance on the database system, just as you do in your on-premises databases. The advantage here is that the activities can be managed using features provided in OCI console. For example, you can apply system patch or database patch. You can scale up the database resources. You can automate disaster recovery. All this can be initiated from the console or CLI without performing any action manually. To summarize on this lesson, assess your database requirement based on workloads, the kind of management you wish to have, the control you need, the consolidation requirement, the dependencies, the data residency regulations, or your corporate policies, all such attributes that matter, and based on that, you should be able to choose the right Oracle database service in OCI. I believe this will be helpful. Thank you. Hello everyone, welcome to this next lesson on database migration. Here we are going to learn about the different migration types and modes of migrating Oracle database. At a high level, we'll get to learn about the different methods which are available to perform database migration and which of these methods fit into the different migration types and modes. For migrating Oracle databases, we can perform these operations either in an online or offline mode. So what do we understand by the online or offline mode? Let's start with the offline mode. In an offline mode, this is the safest mode of performing migration, provided you can get the required downtime to perform migration. Your application remains offline for the entire duration of the migration. Users cannot add changes into the source Oracle database once the migration has been initiated. Since the database changes are frozen, post-migration, the target Oracle database would be an exact copy of your source data. Once the migration is over, you have to reconfigure the application to point to the new target Oracle database and perform the validation. Overall, the entire migration activity demands higher downtime. This mode could be adapted in non-production database, but when it comes to the production databases, too much of downtime may not be approved as it will affect your business. Thus, an alternative to this mode is the online mode of migrating Oracle databases. With this method, the source application and databases are accessible even when your migration is underway. It becomes a two-step process. At the first step, a point-in-time copy of your source Oracle database is replicated into the target Oracle database, and then it applies to the target all changes that was performed in the source Oracle database while the replication was going on. End of the migration, the target is running in sync with your source Oracle database. This mode incurs either zero or non-zero downtime. You can eliminate complete downtime by reconfiguring the application at target environment so that the application can automatically point to the target database once the migration is completed. There are different migration methods that can be used either for online or offline mode or may be used in combination to perform the migration. This mode can be used while migrating Oracle databases on same or heterogeneous platform. Some methods also support migrating from non-Oracle databases into Oracle database in an online mode. The next topic is to differentiate between the types of Oracle database migration. There are two different types. Let's talk about the first migration type, that is physical migration. This type of migration involves copying of the database blocks from the source Oracle data files to the target Oracle database platform. It requires that the source and target database versions should be same, and it will be a complete copy of your source database, and you cannot selectively copy data from the source objects. The other type is the logical migration. This creates a copy of database objects by accessing the database logical structure. It does not have to look into the physical organization of the database. Here the advantage is that the database version of the source Oracle database and target could be different. You also have the option to migrate only required objects and data based on need instead of migrating all. Hence, you may choose either of the methods suitable to the requirement and by measuring the differences. Here again, you can perform the migration to same or heterogeneous platform using different supported methods. You can also perform logical migration from non-Oracle to Oracle databases as well. Let's take a quick look into the different migration methods that Oracle provides for performing migration. One of the simplest migration method is DataPump, which can support logical migration but in an offline mode. You can also use this method for cross-platform migration. Then we have Recovery Manager or RMAN. This method supports physical migration but in an offline mode. In some combination, you can use it for performing online Oracle database migration. This can also support cross-platform migration. We also have DataGuard and Oracle Golden Gate that supports physical and logical migration respectively in an online mode. OCI has come up with automated tools like JDM or zero downtime migration and database migration service in OCI that simplify your Oracle database migration task. Under the hood, they use any of those migration methods individually or in combination to perform the database migration, hiding all the complexities from the end users. Take a pause and look into the different methods, the different migration mode, and the types they support, and some special considerations to be made for few of these. This was a short lesson to introduce you to different migration type and the modes in which you can perform them, depending on the amount of downtime that can be tolerated. You got a glimpse of the different migration methods which Oracle provides for migrating source Oracle databases and some supported non-Oracle databases as well. As we progress, we'll briefly understand each of the different migration methods in the lessons that follow. And I hope this was helpful to you. Thank you. Hello everyone. Welcome to this lesson on database migration process. Migration process basically represents a structured workflow to achieve successful Oracle database migration. And the objective of this lesson is to teach you on the different steps involved, which you can adopt in your migration project plan. Let's then proceed. As you intend to migrate to OCI database service, the source Oracle database type could be Oracle or non-Oracle types. Let's first discuss the scenario where the source database type is Oracle. They may be deployed on-premises or in OCI Classic or in third-party cloud or even in the OCI database service. For example, VMDB. For such sources, the target can be any of the OCI database services like Autonomous Database, Exadata Database, or VMDB service. With Oracle database as source, let's understand the migration workflow. Step 1 is the planning phase. Here you look into the database estate, identify which OCI database service to migrate, check the compatibilities between the source and the target OCI database service, determine the method to migrate, etc. All this assessment can be easily performed using Oracle supplied advisors like Estate Explorer. We have Database Service Advisor, then we have Cloud Migration Advisor, and we have Cloud Remigration Advisor tool, each of which we will discuss in another lesson. The next phase is the prepare phase. Once you run these advisors, you follow the recommendation, generate and apply fixes if any, and rerun the advisor to get a past status. At this stage, you also provision the target OCI DB service. Then comes the migrate phase where you perform the actual database migration using the advisor recommended migration method. And finally, the validate phase where you compare the post migration performance and application functional test to confirm the success of the database migration. This is a high level view of migration process of Oracle database as source into OCI database services. Let's now check on the database migration process where the source database is non-Oracle type. The source environment may be on-premises or on third-party cloud. Non-Oracle databases include MS SQL, Sybase, Teradata, DB2, etc. And the target again could be any of the OCI database services. Unlike the migration of Oracle database sources, you can only use logical migration type, and it may be an online or offline mode depending upon the tool or the method you use and the non-Oracle databases they support. The migration process of non-Oracle database also goes through same 4 phases. In the plan phase, you analyze the source non-Oracle database data type, their limits that can be mapped to the data type in the target Oracle database. You identify the list of users and the privileges granted and determine the equivalent privileges that needs to be granted in Oracle database. In prepare phase, you provision target OCI DB service, create the equivalent object definition in the target, and add users with the needful privileges in the target database. In migrate phase, you perform the migration to target OCI database service. You can use some of the migration tools like SQL Developer, Oracle Golden Gate, SQL Loader. Oracle and Oracle partners, they can also help you with your end-to-end migration activity. And lastly, the validate phase remains the same where you run a functional test and performance comparison. Just to put a quick summary of what we have learned, database migration into OCI database service should be very well planned to avoid any pitfalls. Hence, putting the right process will set the direction for a successful database migration. Oracle provides many of these advisor tools. When the source database type is Oracle, you must take advantage of this tool to successfully execute the migration. When the source database type is non-Oracle, you need to have a good understanding of both databases so that you can do the right mapping during database migration. Try doing some hands-on with the migration of non-production database to understand these concepts better. I hope this will be helpful. Appreciate your time with learning in this lesson, and thank you. Hello everyone. Let's continue our discussion on another topic that can make your database migration task easier. How would it be if someone with great experience can provide you the right guidance on how you should go about migrating an Oracle database to OCI database services? That's what we are going to discuss about in this lesson. It's the migration advisor, which are the right set of tools that can guide you to create a proper migration plan before you perform your migration. So let's learn about those. First of this is the OCI Database Service Advisor. While migrating to OCI database, we are often in a confusion to decide which OCI database service would best meet the requirement, and a wrong choice may lead to unexpected results. The Service Advisor simplifies this complexity by advising you the right OCI database service by measuring certain criteria. They can be broadly categorized as you can see here. First is what is the type of service you are looking for. Are you looking for a single instance or a scalable service or a resource pool? Then whether you are looking to deploy in public cloud or in your own data center, what kind of workload exists in your source databases and their usage pattern. Is it OLTP, OLAP, or a graph database, or is it a packaged application database? And is it always heavily loaded or there is a distributed load pattern? And are you looking for a co-managed service or a fully managed service? What kind of data does your database contain? What kind of additional database security features do you need? So based on that, you can choose the right database service that has that option enabled. Do you need access to the host system and also control access of the operator? What is the SLA of your application? What kind of high availability or DR features you need? Control on the backups creation and the retention, and other such miscellaneous requirements like availability of service in certain region, multi-cloud operations, database options, scalability, automation, etc. Service Advisor thus can help you advise on choosing the right OCI database service target based on this criteria. Try accessing Service Advisor using the link below to get a better understanding about this advisor tool. Once you settle on the target OCI database service, next concern is to decide which method should you use to migrate the source database to OCI database. This concern is resolved by Migration Method Advisor. It can be accessed using this link. It provides a web interface where you express your migration needs. Based on your inputs, it can advise all the methods that are suitable for migration. You specify the migration mode and the type, the versions of the source and target, source DB edition, whether standard or enterprise, which is the target database service you are looking for migrating into. They can be based on the recommendations of Database Service Advisor we just discussed. Then you can specify the source platform and DNS and what is the size of your source Oracle database. Using these criteria, it will list out all the automated and manual methods which you can use, their types, the mode, and the underlying technology it uses. It provides you the recommendations as per the best practices. Next, we have an assessment tool to check the readiness of your source environment for migration. It is called Cloud Pre-Migration Advisor Tool, or simply called CPAT, and is supported with Oracle Database 11.204 and above. Running CPAT prior to migration is one of the most important part of your migration plan. It can assess your source Oracle database to determine whether migration would be feasible to the selected target OCI database. It does so by analyzing the source database metadata and doing a compatibility check with the target database type and version. For example, your source may be using some features which is already replicated in the target version. This tool can only be used when your proposed method is logical migration, example DataPump or Oracle Golden Gate. It is not supported for physical migration methods, pre-checks. This tool is already integrated as part of the migration workflow in almost all Oracle database migration tools like Zero Downtime Migration, OCI Database Migration Service, Enterprise Manager Migration Workbench, etc. Now let's understand how does CPAT work. This is pretty simple. It comes as a Java binary which you can download for Linux and Windows and run through the configuration steps. It comes pre-defined with a series of validation checks that it runs to analyze your database objects. Once you connect to the database, you have to invoke CPAT. Outcome of this assessment is a report containing the check name, what is the condition it checks for, result of the check, and recommended actions to run if the result is not pass. It also gives you the option to generate fix-up scripts for all the checks that failed so that you can run them directly on the database to fix the issue. Then we have another advisor tool which is quite versatile in nature. This is the Cloud Migration Advisor tool. This tool is only available to Oracle migration team of experts and is not available for public access. This has been engineered by a team of developers with years of real-world Oracle database migration experience. It can look into your Oracle database estate and identify which are the Oracle databases that can be easily migrated. It can analyze the historical data and advise which should be the target OCI database service that could be idle for a specific Oracle database source. And then it will recommend the optimum migration method to use based on the target OCI database service and downtime requirement. This is the workflow for Cloud Migration Advisor. It begins with the collect phase. It is the responsibility of customer to run the extractors on the different source Oracle databases that they wish to migrate. Extractors are binaries that can extract metadata information from your source Oracle databases into dumps. There is CPAT, CSP exporter, OEM collector, or Excel. You can use any of these extractors to collect this information. The output of these extractors is then provided to Oracle to upload into Cloud Migration Advisor. Then you provide more details required for the migration like downtime, the host details, network bandwidth between the source and the target environment, and any need of upgrading the database along with the migration activity. Along with this, you create a migration scenario, which are like grouping databases with similar attributes, say databases that can be or cannot be upgraded, then choice of the target types, their migration methods, migration priority based on downtime, etc. Finally, it generates the solution for the created scenarios in previous step. It shows the different suitable methods based on the chosen priority like complexity and downtime. And based on this outcome, you select the most suitable method for migration. Now let's move our focus to one last tool, that is Oracle Estate Explorer. Unlike the Cloud Migration Advisor, this tool is publicly accessible and customers can themselves assess the readiness of their source Oracle database for migration to autonomous database. Look into your database estate and determine which are the databases that can be migrated to autonomous database, which are easier or complex to migrate. You can explore your database estate, prioritize, validate against certain test criteria, analyze those results. All this can be done rapidly in a more flexible manner. These assessments provide an overview of your current database estate, the number of hosts, the CPUs, the number of databases, links between the different databases, databases types, versions, and details around different attributes like locations, CPU count, cores, platforms, etc. It also ranks database based on how much they align with the autonomous database prerequisites and the amount of effort needed for remediation. You can also see the remediation advice, like what action is needed for that remediation. It can help to optimize your database migration, estimate the migration effort for you to choose the suitable migration method, group databases based on various characteristics like version, character set, or business criteria like critical applications with high SLA, etc. Now to quickly highlight the Oracle Estate Explorer tool capabilities, unlike other tools, they allow you to analyze thousands of databases in few hours than working for days. It is based on Oracle Apex and provides a nice intuitive interface with effective visualization of your findings. By default, it comes predefined with several test cases, but you can extend the list by creating some of your own. Then you create different migration scenarios by picking from this test catalog and assign weightage for each of the test types. Validate those scenarios against your database groups, analyze those results with different visualization and drill down features in order to conclude which databases are easier to migrate and how much of remediation effort would be required. For situations where you cannot grant access to the tool, you can generate high quality PDF reports and share them with the different stakeholders. You can set up and perform the analysis on your own using this tool. You don't have to share any data with Oracle to analyze. It has a very low installation footprint and you can install it anywhere. It can be in cloud compute, in your on-premises system, or even in your laptop. To wrap up here, creating a foolproof migration plan is very important for a successful migration strategy, and these advisor tools provide a very good foundation for achieving that. Through these tools, you can determine the ideal target OCI database service to migrate, the suitable method, the complexity in the migration, the remediation effort needed, grouping your migrations and creating an optimized migration plan, preparing for consolidations, etc. By analyzing your databases across different attributes and prioritizing them, you can develop a migration plan that can promise to be successful. I believe this was informative and helpful. Thanks for watching. Hello and welcome to this next lesson. Here I am going to discuss about one of the migration method used for migrating Oracle databases. I assume you might have already heard about this multiple times while interacting with database administrators. I'm talking about RMAN or Recovery Manager, which is one of the method that can be used to migrate to OCI database service. Let's understand a bit about RMAN. RMAN is Oracle backup and recovery client that can be leveraged to perform database migration of Oracle database. It is used to perform backup of your source Oracle databases. You can use that backup to instantiate a copy of the database using RMAN restore and recovery feature. You can also automate and administer backup strategy using this tool. This method takes copy of database blocks and writes to backup pieces, hence it's a physical migration method. It only copies used database blocks of your source database files. Advantage with this method is that you can take full backup or incremental backup of your database. This capability enables you to perform database migration with a short downtime. While migrating to OCI database service, your backup pieces has to be secured with the encryption before being transferred to OCI object storage or the target OCI database service compute. When you're planning to migrate to OCI database service, you need to take into account certain prerequisites. You must have a compatible character set between your source and target OCI DB service. This you can ensure while provisioning the required OCI DB service. For complete migration, you must have the source database in archive log mode so that the changes can be extracted from the point of initial load. The source platform must be supported for Oracle database migration when you're performing a cross-platform migration. And if you are not adopting an online migration method, then you should be prepared for a small downtime to finalize the database migration. Migration from external Oracle database sources to OCI would require transfer of backup pieces to OCI destinations. You must have a faster network bandwidth between the endpoints to allow faster transfer of these files in order to reduce the overall duration of the migration. Let's now discuss on the different options of RMAN that you can use to migrate to OCI database services. Using RMAN cross-platform data transport using backup sets, RMAN can transport the database or tablespace data files using backup sets. The source platform can be in any Indian format. Since the target OCI DB platform is Little Indian, if the source platform is of Big Indian, then RMAN does an implicit conversion to Little Indian while creating the backup sets. In this option, RMAN creates backup sets of data files and data dump files of the tablespace metadata. This option requires the source database and tablespaces to be opened in read-only. Then the RMAN convert transportable tablespace with data pump option. It allows the database migration by transporting only the application tablespaces where you have to perform the Indian format conversion manually using the RMAN convert command. This method too allows cross-platform migration. You can convert the source tablespace data files, which may be Little or Big Indian, into Little Indian format since the target OCI database platform is Little Indian. Here too, you need to open the application tablespaces in read-only mode. Then there is the RMAN transportable tablespace with data pump option that allows transport of tablespaces without the need for conversion. This requires the source to be in Little Indian platform, same as the target OCI database service platform Indian. You don't have to keep your source tablespace in read-only mode. This is in contrast to what was required in the previous two options. RMAN cross-platform PDB option. This is used for migrating PDBs in source Oracle databases to PDBs in OCI database service. Source database again has to be of Little Indian platform. And before you initiate migration, follow the steps to close and unplug the pluggable database. Lastly, RMAN allows you to create a duplicate of your active source Oracle database using RMAN duplicate from active database option. The source should be of Little Endian platform. You can use the RMAN duplicate target database from active database command to initiate migration. Few points to be noted when you are using RMAN to perform the migration. While working on production migration, you should restrict access to the database in order to freeze any changes going into the source Oracle database for a complete migration. And follow the migration guidelines when migrating source databases that are encrypted. With RMAN, you cannot migrate source Oracle databases to Autonomous Database as you do not get access to the Autonomous Database platform. This brings us to the end of this lesson. To summarize, RMAN migration method is a physical migration method where you can use to migrate your source Oracle databases to co-managed database services in OCI. It provides different options to migrate and also supports cross-platform migration into OCI database service when your source platform may or may not be in Little Endian format. Hope this has provided you with the beginner information that you can use to plan your migration to OCI database services using RMAN. Thanks for watching. Hello everyone, welcome again. Here in this lesson, let's learn about another migration method that you can use to migrate your source Oracle database into OCI database service. Oracle provides one of the widely used utility for taking backup. It is called Data Pump. This allows you to take the logical backup of your database that can be imported into target OCI database service. Thus, Data Pump is used to perform logical migration of your source Oracle database. As it creates a logical copy of your database, it is independent of the source and target database platform. For the same reason, the character set of the source and target database does not matter. You have the option to selectively migrate database objects. You can migrate the full database or selected schemas or just few tables. This migration method would require comparatively more downtime, though the downtime could be minimized by following some guidelines. This method can be used to migrate source Oracle databases to any of the OCI database services by following the migration path for the source Oracle database version to the target OCI database service version. Like RMAN, Data Pump utility provides options for migration in addition to the conventional method that we just discussed previously. Let's check those. First of this include Data Pump transportable table space, which will allow you to move application table spaces selectively, which are self-contained. You can use this method to perform cross-platform migration, but the source platform has to be Little Endian. Example, Windows to Linux Oracle database migration. Character set must be compatible between the source and target database. And before you execute the Data Pump utility, the source table space has to be in read-only mode. This is comparatively faster than the conventional Data Pump without any options. It takes the metadata export of the table spaces and then you have to copy the data files physically to target and import the metadata into the target database. This option supports migration into base database. You can also migrate to Exadata DB service, which may be in public cloud or in Cloud at Customer. The next option is full transportable. This option can be used to migrate the entire database, which are at version 11.203 or later, and then the mandatory prerequisite, which requires the character sets to be compatible between the source and target. It requires all the application table spaces to be in read-only mode so that no changes can be pushed into the database. Hence, you should alter the table space status before you initiate migration. You should use the option version equals to 12 when you are taking the Data Pump from the source database that is on 11.203. Likewise, the supported target OCI DB service could be Base DB or Exadata DB service. To wrap up on the Data Pump method, this is the logical method that is widely used for migration across SAME or cross platform. It is highly essential to have a faster connectivity between the source and the target database environment, as it needs to transfer the dump files to target destination after the dumps have been created at source. When you're planning for the complete migration to target database, you must disable any changes being pushed to the source database before you begin migration. This will keep the target database exactly in sync with the source database post migration. These are some of the quick guidelines about using Data Pump and its options. I hope you like the discussion. Thank you. Hello everyone, welcome to the next lesson. Now you are going to learn about leveraging remote cloning method to perform migration to OCI database services. Having some prior understanding about Oracle multi-tenant architecture, it can help you understand the concepts better from what is being discussed here. However, if you do not have, I recommend you to just watch some short video on Oracle multi-tenant architecture, which you can find in Oracle portal or in YouTube. Let's just understand a bit about this migration method. With remote cloning, you create a copy of source Oracle database that may be on premises or on third-party cloud into OCI database service by using the database link feature of Oracle database. The database link in target OCI database to source Oracle database becomes a channel to clone objects to target OCI database service. This method supports migration to base DB as well as Exadata DB service. It is based on the cloning feature of Oracle multi-tenant architecture that allows you to clone a remote database as a PDB or pluggable database and plug it into the container database in Target using simple SQL statements. The Oracle source to be migrated may be a pluggable database or it may be a non-container database at release 12.1.02 and later. It requires source DB to be on little Indian format. The character set and also the national character set of the source DB must be compatible with the target OCI database. There should be an established secure network between your source database system and target OCI DB system in order to clone source database using the database link. Large size databases, they can be migrated faster if you have a faster network between your source and target system. Let's check two specific scenarios for migration. One, the source is a pluggable database, and second, your source is a non-container database. When the source is a pluggable database, then you create a database link from target container database to the source pluggable database. It requests the source pluggable database to be opened in read-only mode. You create a clone of the source pluggable database in target container database using simple SQL commands and the DB link which you created earlier. Post migration, you can open the PDB in read-write mode. When the source is a non-container database, open it first in read-only mode. Note that there is no pluggable database at source. It is the whole database itself. The database link you create is from the target container database to this source database itself, which is going to be plugged as a PDB or pluggable database in target database using this DB link. You create a clone of the source database using simple create pluggable database SQL commands. One additional step you need to perform before opening the target pluggable database is you must run non-CDB to PDB routine first to convert the database to a PDB. Then you can open in read-write mode and operate just like any other pluggable database. To summarize on this lesson, remote cloning provides an easy method of migrating source Oracle databases into OCI database with simple SQL statements and with minimal configuration. However, you must have a very good network bandwidth between your source system and the target OCI DB system for migration to complete faster. Also note, this is an offline mode. You have to keep source database in read-only mode. Hence, you cannot post any new database changes into the source database. I hope this provided you a high-level overview of this method. You can dig deeper while performing migration using this method. Thanks for watching. Hello everyone. Next in the sequence of migration methods is the unplug and plug method, which is again a capability added with Oracle Database multi-tenant feature. As advised earlier, please have a brief overview of Oracle multi-tenant architecture, which will make your understanding of this lesson simpler. Oracle multi-tenant architecture provides multiple capabilities that offloads many of your database management tasks. One such feature is unplug and plug feature. that you can use to migrate pluggable databases to different container databases, which may be at the same location or remote. As in this case, it is your target OCI database service that may be a base DB or into Exciter DB deployed in OCI public cloud or in cloud at customer. While migrating to OCI database service, you can unplug the pluggable database entirely from the source Oracle database and plug it into a container database in OCI database service. You can immediately connect to the database as soon as it is plugged and opened. It's a feature in 12c release. The source Oracle database can be a pluggable database or non-container database, but it should be on 12.1.02 or later. Again, the source platform should be of Little Endian. Like remote cloning, the database character set and national character set of the database should be compatible. In general, this process requires secure transfer of database files physically from the source to the target environment. So you must have a faster network between your source database environment and the target OCI DB system. Let's check two specific scenarios and how does migration works in that case. First type is that your source is a pluggable database. Before you initiate migration, first step is disable all connection to the database. So you must close and unplug the pluggable database. Then create XML metadata file of your pluggable database to be migrated. The file contains the list of data files that will be plugged into the target OCI container database for this source pluggable database. Secure copy the XML metadata file and the data files of the pluggable database at source into the destination with appropriate directory structure. Run the create pluggable database SQL command while being connected to the container database to create the pluggable database in target OCI container database. You may use the PDB file name convert parameter to map the source pluggable database directory structure into the different directory structure used at the destination container database. Next is the scenario where the source may be a non-container database that is not based on multi-tenant architecture. This is usually the migration case where you consolidate multiple source Oracle databases into a target high-performing container database in OCI. Here the migration has a small change. There is no unplug step. You have to open the source Oracle database in read-only mode. Then generate XML metadata file of source database using dbms_pdb.describe routine, which is already provided in the database. Note that the database release should be 12.1.02 and above. Transfer this XML metadata file and all data files belonging to the source database to the target OCI container database directory structure. Create pluggable database using SQL command while being connected to the container database in target. This will refer the metadata file while creating the pluggable database in OCI database service. You must use the PDB file name convert parameter to map the source data file directory structure to that in the target OCI database directory structure. All the different steps we discussed does not complete the plugging process until we complete one step. Since the source is a non-container database, after moving to the OCI container database, you must run non-CDB to PDB SQL to convert that container database to a pluggable database. This will remove unwanted metadata from the system table space of the new pluggable database in OCI. You can then open the new pluggable database in OCI database in read-write mode and it would be ready for operation. Thus, in this lesson, we see how easily you can migrate database from non-Oracle Cloud environment to OCI DB service environment with few simple steps. As you perform the complete migration task, forbid any changes to the source pluggable database so that after migration is completed, the application should be configured to perform all transactions from the target database environment. This method resembles more to a combination of physical and logical migration. Hence, it is comparatively faster way to migrate source databases into container-based target OCI databases. Migration duration can be significantly reduced by having a faster network between the source and target systems. I guess you learned a new way to migrate Oracle databases, which may be on a container or non-container based architecture, and hope it was helpful. Thank you. Hello everyone. Welcome to this next lesson. We learned about some of the utilities that we can manually execute to perform Oracle database migration. In this lesson, let's take some of the GUI tools which Oracle provides as a means to migrate Oracle databases. Let's start then. First of this is the migration workbench feature, which is available with Oracle Enterprise Manager. You get a seamless migration experience when migrating source Oracle databases to OCI database services, which must be on Enterprise Edition. It does not support Standard Edition. Migration effort is simplified with the guided workflow, which can automate the plan for migration, selection of the right migration targets, choosing the right migration method, comparing the performance before and after migration. Migration Workbench supports two of the different migration methods, data pump and transportable table spaces. Data pump can migrate full database or selected schemas, while transportable table space method can migrate table spaces. And it can provide a near zero downtime migration approach. In order to decide which method would be right fit for specific scenario, there are certain guidelines. For example, if your database is less than 500 gigs, you can use data pump. And if it is greater than 500 gigs, you can use transportable table space. If there is a change in the character set or the architecture change, you can use data pump. And if you need minimal downtime, then can use transportable table space. So these are few of the guidelines, but you can refer the documentation for few other scenarios. In terms of support metrics, Migration Workbench supports migration of Oracle databases from 11 to 04 onwards. It can migrate both CDB and non-CDB databases to OCI databases. And depending on the method of migration you choose, migration may incur near zero downtime or more. Migration is a three-step process in Migration Workbench. The first step is plan phase. This is the most important step in database migration. Failing to set the right migration plan can lead to migration failure and affect your business strategy. Hence, a thorough assessment of your database estate is done to identify candidates suitable for migration based on the different factors. In this phase itself, you can also plan consolidation of multiple source Oracle databases into OCI database services. Enterprise Manager provides migration planner that can support your consolidation needs and also advise on sizing a destination by analyzing the historical workload metrics. Once you have prepared and evaluated the plan, the next phase is actual migration. As discussed earlier, you can either use transportable tablespace method for a near zero downtime migration or data pump method based on the requirement criteria. Another phase of the migration task is analyze. In this step, you monitor the migration task like current activity, recheck validation results, recommendations that you must apply before submitting migration, completed or in progress steps, errors if any, and their details. There is also a post-migration analysis like object count, record counts in table, compiled routines, DB size, earlier scheduled jobs that needs rescheduling, etc. You can also compare the performance in target OCI database with that of the source Oracle database before you can consider that the migration has completed successfully. Finally, you need to perform a cleanup activity, which includes removing the dump files used for migration from object storage and the data pump directory after the migration has completed successfully. This is the migration workflow, how it looks when we expand the three-step process. Begins with first creation of the migration activity. Complete the required prerequisites for migration. This includes completing Migration Workbench prerequisites, source and target credential creation, connectivity, granting privileges, uploading migration tools like Instant Client, Cloud Pre-Migration Advisor tool, and some prerequisites required for data pump and transportable tablespace migration method. Optionally, you may add some customization like pre and post-run scripts that can be invoked when you are using data pump or transportable tablespace migration method. Mandatorily perform the migration readiness check before even submitting the migration. You have to run Cloud Pre-Migration Advisor tool when you are using data pump method and transportable tablespace migration readiness check tool when using transportable tablespace method. These tools can identify all possible failures and recommend actions to resolve them. After applying those recommendations, you must repeat migration readiness check to ensure all requirements criteria passes the validation. Once the check return passes for all criteria, you choose to schedule and submit the migration job. This will initiate the migration using the chosen method, which you can monitor then or monitor at a later point of time. The next three boxes you see inside the dashed box represent the analyze phase, which you have already discussed previously. You can monitor each step as the migration progresses and analyze the details. You can use SQL Performance Analyzer to identify the impact on performance as a result of this re-platform. It generates a performance report to make a clear distinction between how many of the SQLs have improved performance or there is no change in the performance and how many have regressed, and also provides tuning recommendations to apply and improve the performance. And then comes the concluding step to indicate the migration has completed successfully and you must clean up the environment. Let's now take a look into another GUI tool that you can use for migration. It is one of the widely used tools for connecting and performing database development and management operation on Oracle database. It is SQL Developer from Oracle. This tool provides capabilities to automate your migration using guided workflow called Migration Wizard. It supports migration of both Oracle and non-Oracle databases in an offline mode to OCI database services, which includes autonomous database as well. It basically uses logical migration method to perform the migration. The only supported non-Oracle database sources include MS SQL, Sybase, Teradata. While performing the migration, please check the support matrix of non-Oracle database sources so that you can use the right version of SQL Developer tool. Since it's a GUI method, it provides greater flexibility of customizing your migration, hiding the complexities of manually preparing the command line options. You can choose which schemas to migrate, choose a specific objects to migrate, and also be able to map data types to the source equivalent in target database. It supports data pump method for Oracle database sources, and for non-Oracle databases, it can use SQL loader or prepare conventional insert statement to load data into target database. Before migrating third-party databases, you must first capture source database objects definition. This is called captured model. And there are two different ways to capture source database structures. It can be an online capture or offline capture. Online capture provides a guided approach to migrate using Migration Wizard that takes you through a sequence of steps. It is preferred method primarily for supported non-Oracle database sources. However, this method is commonly chosen for migration of both Oracle and supported non-Oracle database sources. In an offline capture approach, you have to manually prepare a set of offline capture scripts. The offline capture scripts has to be executed outside SQL Developer. It will generate several files with .bat, .sql and .ocp extension. One of these is the offline capture controlling script, which when executed will generate object capture properties or .ocp file that contains the information about the converted model. The converted model is a translation of source object definition into the target database equivalent. You will load this .ocp file to create objects in target database using SQL Developer load database capture script out. For some objects which may not undergo a successful translation would fail to get created in the target Oracle database, for them you have to manually modify the script with Oracle equivalent and then load them into the target database. With this, we have reached the end of the lesson. Here my objective was to let you know how you can perform your source database migration into OCI database services using some of the Oracle tools which I am sure you are already using it regularly. You see an advantage with SQL Developer. You can migrate supported non-Oracle databases into OCI database, which in itself is a challenging task due to the disparate database types. Besides that, both these tools provide a guided approach to database migration using migration interfaces that are very informative in nature and also aim to overcome the manual effort you usually would have to deal with when migrating databases manually. I hope this was a helpful lesson. Thank you. Hello everyone. Welcome to another lesson on Oracle Database Migration Method. In this lesson, I'll be discussing briefly about another Oracle product that can enable you to achieve logical migration of Oracle or supported non-Oracle databases with zero or least downtime. I'm referring to Oracle Golden Gate. Let's proceed. What exactly is Oracle Golden Gate? Just to have some background on this product, Oracle Golden Gate is one of the most popular tool widely adopted by organizations to achieve their real-time data replication needs to conform with Oracle Maximum Availability architecture. Data is replicated at real time to a remote copy of the source database that serves to address the business continuity strategy of the organization. It is based on microservices architecture with each capability component acting independent of each other. It provides flexible deployment option. You can deploy on-premises or in cloud. It is also available as a service in Oracle Cloud Infrastructure. The modular nature enables you to configure a hybrid deployment where some components of the tool can reside locally in your source system and communicate to another component of Golden Gate which is deployed in cloud. You can design your own replication strategy, and it provides different mechanism to troubleshoot the replication. It supports various replication topologies like one-to-many, many-to-one, unidirectional, bidirectional, or cascaded, etc. Not just it supports heterogeneous replication to relational databases, but it can also support real-time streaming of data to big data platforms. And it supports both Oracle and few non-Oracle databases replication as well. To give you a quick understanding of its core functionality, it has an extract process which reads the database changelog files and writes them into its own format into files called trail files. These trail files contain database transaction details in the same sequence as it occurred in the source. These trail files are then transferred to the target database server, and another process called the replicate process reads these files and applies those changes in the same order in the target database server. This way it keeps it in sync with the source database. Because of its core functionality, it is used for performing zero or least downtime migration of databases. Let's understand how this is done, taking Autonomous Database as a target OCI database service. In the upper left image, you see there is a source database in on-premises, which is getting migrated to OCI database service, that is Autonomous. For migration of source databases to OCI, you have to configure two things. One, create a point-in-time copy of the source database using the DataPump utility to be used for initial load. The intermediate medium for storing dumps is the OCI object storage. Then at the same time, while taking the dump of the database, you must also start the extract process, which will capture all the changes getting into the database from the point the database dump was being taken. Once the import completes in the target, you can apply those incremental changes to the target to bring it in sync with the source. At one point, when both databases are in sync, you can plan the cutoff and make application point to the target database service. Note that it supports all Oracle database services as target in OCI. OCI provides two different options for you to provision Oracle Golden Gate. You can either use Golden Gate apps in OCI Marketplace, or you may choose the managed OCI native Golden Gate service. Irrespective of the deployment option, you can choose either of them to perform zero downtime migration of source Oracle databases into OCI database services. To conclude on this lesson, Oracle Golden Gate enables you to perform logical migration with zero downtime capabilities that you can use for cross-platform or cross-database migration. The microservices architecture provides you REST-enabled web interfaces, not just to do the required configuration of the individual processes, but also provide nice interfaces to monitor and analyze the performance of each core component. Because it performs real-time replication, the target database is always kept in sync with the source so that you get more time to plan your cutoff date and finalize the migration. The purpose of this lesson was just to give you an overview of this tool, and I hope you got the basic idea about what this tool is and how you can leverage it to achieve zero downtime migration. Thanks for watching. Have a great day. Hello everyone. Continuing our discussion on database migration methods into OCI database service. Here we will learn about one of the recommended migration method that provides hassle-free migration into OCI database services. It's the zero downtime migration, commonly abbreviated as JDM. Let's begin and understand its key capabilities. Zero downtime migration or JDM is complete end-to-end automation tool for migrating Oracle databases. You can achieve zero to minimal migration downtime, which may last up to 15 minutes or lesser. It is built with principles of Oracle Maximum Availability Architecture and leverages technologies like Oracle Golden Gate, Oracle Data Guard to achieve high availability and online migration capabilities. You have the flexibility to choose your migration method and modes when migrating with JDM. For example, you can choose to do a logical online migration for critical production database, and for migrating a development database, you can simply choose the physical offline migration method. Accordingly, appropriate migration method is used to complete the migration. In line with the migration activity, you can complete additional activity in one go. Example, database is due for upgrade to next higher release, or you have plans to migrate from non-container to Oracle database multi-tenant architecture. Such activities can be completed along with the database migration activity. JDM offers greater flexibility and automation in performing Oracle database migration. You can customize workflow by adding pre and post-run scripts as part of the workflow. You can run pre-checks to evaluate migration so that you can perform recommended action prior to initiating migration. You can audit migration job activity and user actions, control the execution like pause, resume, terminates, schedule the run, and other such capabilities. Before you decide to use JDM, you must know what JDM supports so that you do not end up trying some migration which JDM cannot achieve. Your source Oracle database must be of version 11.204 and above. It supports standard and enterprise edition database for migration. You can use JDM to migrate databases that may be on-premises or in non-Oracle cloud and even within Oracle cloud. It can perform cross-platform migration, and the supported platforms are Linux, Oracle Solaris, and AIX. JDM automates migration using standard Oracle migration methods and technologies which include RMAN, DataPump, Database Links, DataGuard, Oracle Golden Gate, etc. Technically, working with JDM includes very simple steps. Download the JDM binary from My Oracle Support as it contains the latest updates. Set up and configure the binary by following instructions available at the same MOS Note ID. The host where JDM is configured is called the JDM host. It is the JDM host where all migration orchestration happens. You configure source and target connection, set up the SSH and sudo configuration with the source and target, open the ports which are required, creation of the dump destination, running CPAT on source database, and evaluate the migration before actual migration. Use the response file to define parameter values which JDM fetches while running the migration. You can also customize the migration job, user actions, which are basically scripts that can be executed before and after a particular phase. They are denoted as pre-action and post-action scripts. This is a single-page view of JDM in terms of what are supported source database environment like on-premises, non-Oracle cloud, and OCI. Then in the middle section represents the JDM process where you first perform readiness check, the different supported methods under physical and logical for online and offline mode, then the post-migration validation, cleanup, and finally marking the migration as complete. At the extreme right, you can see all the targets that OCI supports, which could be on-premises or OCI. Spend few minutes watching this page to build a complete image of JDM as a whole. To wrap up on JDM, it is a very efficient tool for migrating Oracle databases. You can migrate a single database or the entire fleet of databases can be migrated in parallel. It also provides several control features like it allows you to check the status or terminate the job as the migration progresses. Much of the complexities associated with manual migration are entirely shielded from the end users, and all migration actions are automated under the hood. I suggest to refer Oracle documentation to understand JDM and its configuration in more detail. I believe this lesson gave you some initial idea on this tool and its features. Hope this would be helpful to you. Thank you. Hello everyone, welcome back. We learned about zero downtime migration, which provides end-to-end migration automation into OCI database services, but it requires some manual configuration initially. OCI simplifies this step by providing you with a managed database migration service in OCI. Let's learn about this migration service and its capabilities. Just to give an overview, OCI Database Migration Service is a fully managed database migration service in OCI. Oracle manages its configuration, upgrades, and orchestration. This is deployed in its own service tenancy, and Oracle manages its sizing based on demand. It is based on Oracle Maximum Availability Architecture and utilizes methods to provide maximum availability. Under the hood, it uses JDM to perform the migration. It provides a web interface for you to provide necessary database migration configuration details, and internally it feeds those required values to JDM to perform the migration from source to target database. You provide inputs required by the service to create migration workflow. It provides you various control mechanisms in the web interface, which includes checking the status, pausing and resuming it, rerunning the task, terminating the migration job, and pre-checks, etc. This also provides some advantage for being an OCI-based service. It is integrated with other OCI services like IAM, monitoring services, which you can use to monitor the database migration resources and alarms, example CPU utilization, memory utilization, etc. In terms of support, the OCI Database Migration Service supports online and offline mode of migrating source Oracle databases, which may be physical or logical. You can migrate standard and enterprise edition database with minimum version being 11.204. The source databases may be on standard edition or enterprise edition. Supported source Oracle database platform can be from Linux, Oracle Solaris, and AIX. The source environment could be on-premises or on non-Oracle cloud or even in OCI. It can support any of the OCI database service targets like base database, Exadata database, and autonomous database. This is one-page view of OCI database service in a nutshell. On the left, you see all the different source databases that are supported. You can have standard or enterprise edition database. They may be hosted on-premises or maybe in third-party cloud like AWS, RDS, or Azure. Even you can have non-autonomous databases in OCI as sources for migrating to target autonomous database. In the middle section, you see the architecture for database migration. It is integrated with Cloud Pre-Migration Advisor tool or CPAD to run pre-checks before initiating the migration. There you see that it supports both online and offline migration solution. For online migration, it does initial load using DataPump via DB-Link or the storage as transfer medium. DB-Link is chosen for smaller size source databases with less than 50 gigs, provided you have a good network bandwidth between the source and target OCI database. For larger size databases, you can choose DataPump with OCI object storage or with OCI shared file storage service depending on the target type, which may be autonomous or non-autonomous database targets. It uses OCI Golden Gate service for complete synchronization of target database with the source by replicating change data that might have occurred after the initial load extract from the source. And as discussed earlier, this mode provides a near zero downtime migration solution that allows your application to keep running while the database migration is in progress. In case of an offline migration, you just perform an initial load into target. No synchronization happens after the initial load. Hence, for a complete migration, you must keep your application offline, else any changes posted beyond the point when the dump was being created will not get extracted. The initial load is a point-in-time copy of the source Oracle database, which it creates based on the option you choose for transfer media. That is DataPump via database link or via storage. Finally, in the extreme right, it represents the supported OCI database service targets, both autonomous and non-autonomous database services. To wrap up on OCI database migration service, it is a fully managed, highly performing migration service that elevates your self-service migration experience with complete end-to-end automation. It runs in its own tenancy as a multi-tenant service. It can completely automate the migration of your source Oracle databases into OCI database depending upon your application requirements. You just have to define your migration requirement via the web interface and submit the migration job. Beyond that, You can monitor the progress, and when the migration completes successfully, configure your application to the target database. As with every migration best practices, make sure you first perform a dry run with non-production database before attempting on production. I hope this was helpful. Thank you.
Welcome to this lesson on an overview of OCI Monitoring Service. Monitoring is one of the foundational services of the OCI Observability and Management Platform. The service is designed to help you with actively and passively monitor cloud resources. So what is active monitoring? Active monitoring is about actively probing resources to assess the health and performance, like for example, how you wanted to probe and run a health check of a web server. Passive monitoring is about observing a data point as it happens naturally. An example would be monitoring the CPU utilization of an instance. The service uses a concept called metrics to monitor cloud resources. Majority of the OCI service emit different types of metrics. In our previous example, we saw that the CPU utilization is one type of that metric emitted by the compute service. There is another concept called alarms that could be used to send alerts for notification purposes. You can send alerts to different destinations, and this feature is enabled through an integration with the notifications service. Monitoring provides dashboards, a single pane of glass to monitor cloud resources, and these dashboards are created based on metric selections. And using these dashboards, you can visualize metric data in a more user-friendly way. Now, there are different ways you can access the monitoring metrics and alarm data. You can use the OCI console, CLI, command line interface, and APIs. Let's look into some of the capabilities of this service. OCI monitoring automatically collects and stores metrics from different OCI services like compute instances, load balancers, databases. And these are all classified and grouped in a way to quickly access and configure them. Monitoring provides you a flexible query language. We call it as MQL, monitoring query language, and that can be used to retrieve, analyze, and aggregate metric data. Using MQL, you can write complex queries to filter down the data, and that would help you to narrow down to the issue that you're troubleshooting for. So in our previous lesson, we spoke about the integration of the pillars of observability. So here, monitoring metrics can be transferred from the monitoring service to other services like the object storage or functions or streaming using an OCI service called the Connector Hub. OCI Connector Hub is a cloud message bus platform that is used to move data between OCI services. A use case here would be with sending metric data to object storage. You would be able to store them for historical data analysis. Monitoring has integrations with other observability services. As an example, using APM, Application Performance Monitoring, and Monitoring Service together, you can monitor or compare the performance of an application with the infrastructure metrics. Another example would be using logging and logging analytics with monitoring. You would be able to correlate the monitoring data along with logs for deeper insights. OCI monitoring is an extensible platform. That means it is not just the service metrics that is emitted into the service. You can also collect custom metrics from custom applications or resources running in a different cloud environment. You can use an API to post or publish those custom metrics into the service. There is also an agent configuration method that you can deploy or enable that agent on the source and then collect those metrics into the monitoring service. Here is an end-to-end workflow of the monitoring service. On the left, you have applications, services, and resources within the OCI environment. This could be running even outside of OCI. These resources are continuously emitting metrics into the monitoring service. The metrics are emitted as raw data points, and then the service would aggregate them. We will see the aggregation methods in a later lesson. This aggregated data can be accessed through OCI Console, CLI, or APIs, or even using third-party monitoring tools like Grafana. The next step is to define an alarm with a condition. And here in this example, we are choosing if the CPU utilization is greater than 80%, that should trigger an alarm. The alarms are configured to send alarm data into the OCI notification service or the streaming service. We will look into the notification service, the different communication channels in a later lesson. To summarize, we had a quick look into monitoring service. We saw some of the capabilities and also concluding with an end-to-end workflow. So that's all in here. Let's now move on to our next lesson. Welcome back. We will now see some of the key concepts of OCI monitoring service. We saw the definition of metrics earlier. Metrics are defined as a measurement related to the health, capacity, or performance of a resource. These metrics are logically grouped within different metric namespaces. As you can see in the screenshot, you have a metric namespace dropdown, and here we have selected the OCI Compute Agent, and this namespace contains metrics like the CPU and memory utilization of your compute instances. There are different types of metrics that can relay metric data. The service metrics are those from the native OCI cloud resources. Then we have got custom metrics, which are your own custom metrics that you can publish using an API called Host Metric Data. There is also an agent configuration method where you can enable an agent on the instance and emit metrics from that instance into the service. Dimension is another concept in the monitoring service. You would use dimensions to apply filters to the metric data. Let's say if you want to filter the data by a specific resource ID or filter by the shape of an instance, you can add dimensions with a name value pair and view only those metrics applicable to those selections. The next field, as you see in the screenshot, is the time period that you select along with the metric. You can choose a start time and an end time to filter metrics within this period. Interval and statistics are two different functions, and those are used to aggregate raw data points. Interval is the time interval, how often the aggregation should be done. Statistics is another aggregation function. For example, you may want to look at the maximum reported value of the CPU utilization. And here in the screenshot, we have selected a statistic called a mean, which is referring to the average value of a utilization metric. Metric stream is defined as an individual set of aggregated data. Let's take an example. If you have 10 compute instances and using any metric, the aggregated data for each instance is referred as a single metric stream. So the data here would represent 10 individual metric streams. In the screenshot, you can refer to the different colors in the graph section that represents for each instance. You have an option to combine these multiple metric stream into a single stream of data. And this capability is also referred as one of the grouping function. This grouping function could be used to find the overall, the total utilization of a group of instances in a clustered environment. Let's now look into the concepts of intervals and resolutions and see how those two are related. We saw interval is defined as the time window used to aggregate a set of raw data points. That means you are specifying an interval within the metric query to derive multiple time windows for data aggregation. The resolution is the period between the time windows, and it could be only used through APIs. To compare these two concepts, interval controls the length of the window, and resolution controls the start time of each aggregation window based on the previous window. So here is an example to explain these concepts. Request A is a metric query for the maximum CPU utilization with an interval of 5 minutes used within the last 15 minutes. This 15 minutes is represented from 0 to 15, and this is the overall time range that we choose with the start time and the end time. Now, if you note here, this query is not using a specific resolution value. That means it uses 5 minutes as the default resolution between the time windows. So the first time window for aggregation is from 0 to the 5th minute. The second window is from 5th minute to the 10th minute. And the third window would be from the 10th to the 15th minute. Each time window would result in a single aggregated data point that represents the highest CPU utilization counter for that window. Now, the second example, request B has a 1 minute resolution and the 5 minute interval. That means each 5 minute aggregation window is taken from the data points emitted every single minute. Here in this case, the aggregation starts from 0 to the 5th minute, and then the resolution will be applied after the 1st minute. So the next window would be from the 1st minute to the 6th minute, and then the 2nd minute to the 7th minute, and each window resulting with the highest CPU utilization counter for that window. Statistic is another aggregation function that we use. There are some statistic functions referred in monitoring query language used for creating queries. The statistic function sum is used to return the total of all values or the total of all data points added together. In the example with the query with using sum, we are looking at the total bytes ingested for each day in the logging service. The statistic mean is similar to average, and it returns the value of sum divided by count during the time period. The query here with using mean would calculate the average CPU utilization for every hour. Count is the total number of observations received in the given time period. Here in the query, we are looking for service connector hub errors and to report the total errors in every 6 hours. We are defining a condition that is greater than 1 and is usually used when defining alarms. Max is for maximum, the highest value observed during the period. The same way, we could also use the statistic minimum to find the lowest value observed during the period. Percentile referred here returns the estimated value for the specified percentile. In the example, the query would calculate the 90th percentile of CPU utilization across the instance in every minute. And this is usually used to understand the upper limits of the CPU usage of instances. Alarms is one of the core concepts that will help you to alert and send notifications. In the diagram, you have OCI services emitting metrics into the OCI monitoring service. You have defined an alarm for high CPU utilization. And when the alarm is in firing state, it sends a notification message to the topic that has got different destinations like email, Oracle functions, HTTPS, PagerDuty, Slack channels, and SMS text messages. To define an alarm query, you must always specify the metric, statistic, interval, and a trigger rule. Alarm has got different states once you have created them. OK means the alarm is not in firing state. Firing means the alarm state has been changed from OK to firing. Reset is when the alarm is not detecting the metric firing or even the metric is no longer emitted. Repeat is referred when the alarm is maintaining a firing state and you have configured to repeat notifications to those destinations. Suppression is another configuration used to suspend alarm notifications during a specified time range. This is usually used to pause notifications or sending alerts during a planned system maintenance. We saw previously the definition of metric used in a query from a metric namespace. For example, OCI Compute Agent provides you CPU utilization, memory utilization, the total bytes returned to the disk, load average, etc. OCI VCN gives you several metrics. Then you have OCI block storage level metrics, OCI object storage for object storage metrics. The next component is interval. Interval is used for data aggregation. There are different interval values that you can choose depending on the basic or the advanced mode. The basic mode is the UI-driven creation of metric queries. Advanced mode is where you can write your own queries using the monitoring query language. Dimensions is an optional component. You can specify dimension to filter with a name-value pair. Grouping is another optional component, and it is highly useful in aggregating query results. There are two types of grouping function. Group by, which means you can aggregate the query results by groups. For example, grouping by availability domain or grouping by regions. The second grouping function is called grouping. It is used to aggregate multiple metric streams into a single stream. We saw an example in our previous slide to aggregate 10 metric streams into a single stream. Statistic is a component that is used to aggregate raw data points. We saw some of the statistic function in our previous slide. And then finally, comparison operators, and that's used for creating conditions that are used for defining alarms. And that concludes this lesson. To summarize, we looked into the key concepts and terminologies used in monitoring surveys. We looked into metric namespaces, intervals, resolutions, the statistic functions, and then finally alarms for alerting and notifying different destinations. Thank you for watching. Welcome to this demo on monitoring surveys. We are going to look at some of the key concepts of monitoring surveys and see how to access those concepts using the OCI console. So first of all, select the region where you have resources. In my case, I have a few instances running in Australia, Southeast Melbourne region, and then click on the top left burger icon. The monitoring service can be located under observability and management. And let's click on monitoring. The service metrics page is a landing page to quickly select a compartment and a metric namespace. So you can choose the compartment where you have resources, and the metric namespace is a logical container that contains a set of metrics. You would have these metric namespace only if you have resources deployed or running in your compartment. For example, the OCI block store is available because I have instances running which are attached with block volumes. So let's quickly select the OCI compute agent namespace. And you can see the different metrics here collected and the graph representing each metric. For example, you can see the CPU utilization, the memory utilization, and then scrolling down, you can see the different disk level, the disk read and write IO, the disk read and write bytes, the network receive and transmit bytes, the load average, and memory allocation stalls. So going back to the top of the UI, so the different color representation here shows the CPU, for example, in this case, the CPU utilization for multiple instances. So I have about 7 instances running, and the different colors shows the CPU utilization for those specific resources. The next concept that we spoke about is dimensions. So dimensions are filters that you can apply to this data. For example, let's click on add, and you can choose a dimension name with the resource display name. There are different options you can choose. You can choose a dimension value with availability domain, or if you want to provide an image ID or a resource ID. In our case, let's choose a resource display name, and with a value, I wanted to filter for the Windows Server. You have the option to add multiple dimensions, but let's create one dimension here and click on done. So you can see the graph has been updated, and now looking at the CPU utilization,
I'm looking at the CPU, the utilization for that specific resource, which is the Windows Server. Let's uncheck the dimension and see all the data. The next field is the time range, which you select with choosing a start time and an end time. So the data that you see on the graph would be based on this selection. You can quickly select for the last hour or last 6 hours or 12 hours or so forth. Let's quickly select the last 6 hours, and you can see the chart has been updated with choosing the time axis showing for the last 6 hours and the percentage for the utilization. One of the key concepts of monitoring service is the interval. So interval is the time window where you are aggregating these data points. You have different options to choose. Like, for example, you can choose intervals of 1 minute, which means you are creating multiple 1 minute time windows and measuring the utilization for each window based on the statistic provided. The next concept that we looked was the statistic. You have option to choose, let's say, for example, max represents the maximum CPU utilization for that window. Let's navigate into the Metrics Explorer. So Metrics Explorer is where you can take a deeper look into the metrics and build queries using the basic mode or advanced mode. So again, starting from the top of the UI, you have the time range selection. You can choose the start time and end time. I'm just using the last hour as the time range. We will get into this graph once we select the metric. Let's scroll down to the query section. So the Metric Explorer have two modes. One is the basic mode and the second one is the advanced mode. The basic mode is more about creating queries using a UI driven approach, and advanced mode is more about writing queries using MQL expressions. So in the query section, we have selected the compartment, which is my demo, and I'm going to select the metric namespace, which is the OCI Compute Agent again. I don't have any resource group. Let's select the metric name, which is CPU utilization, and the interval is, let's say, the default, or you can choose different values for the given time range. I'm going to select 1 minute, and let's choose the statistic as max. I would like to use a dimension here, which is the shape used for those instances. And I have instances using three different types of three different shapes. So I'm going to choose the standard E4 flex and then click on update chart. And you can see the chart has been updated, and there are 5 instances using that specific shape, and each color representing a metric stream. So to see the metric stream, there are 2 ways to see those metric stream. You can close the query editor, and expanding the query here will show which are those metric streams. So there are 5 metric streams here, and the name of the instance with the OCID is being shown. You also have an option to convert this graph into a data table with toggling the show data table option here. And you can see the host, the name of the host, name of the instance here with the timestamp percentage value. Scrolling down, you can see the other next set of instances. Here I have for CentOS, the timestamp and percentage values. Again, scrolling down, you can see the remaining instances that are part of that or using that specific shape. If you notice here, the difference between these timestamp is 1 minute, and that's because we have chosen 1 minute interval, and each interval or each window presented with the CPU utilization for that window. Let's go back to the graphical view. And let's click on edit queries to get back to the query mode. So as I mentioned, there are 5 metric streams here. So you have an option to aggregate these metric streams. So these metric streams would combine and aggregate together into one single stream. So if you select this option to aggregate metric streams and let's say update chart. So these are combining the CPU utilization for all those instances together. And usually you would use this grouping. This is also called the grouping function, which when you're using the advanced mode, we will be looking into that later in one of our demo. So you would use this scenario when you have a group of instances and that represents a cluster and you wanted to see the CPU utilization for that entire group. So going back onto the left panel, alarm status is where you would see all the alarms that are in firing state. I don't have any alarms that are in firing state. That's why you don't see any firing alarms here. You have the option to create an alarm from this page, or you can click on the alarm definitions. So I have a few alarms which are already in active state. You can create alarms from this page. And we will be seeing how to create alarms in one of our next demo. So the health check service is a service used for monitoring external facing web services, for example. Or let's say if you wanted to monitor an IP address, you can specify this IP address as the target. You can also mention from which locations you wanted to monitor this IP address and the request type on how to check these IP address, whether using HTTP or running a ping test. So that's all in this demo. We looked into the different key concepts of monitoring service and how to access those concepts using the OCI console. Thank you for watching.
Hello and welcome back to this lesson on notification service. The OCI notification service enables you to broadcast messages through a publish subscribe pattern. Topics are referred as communication channels and subscriptions are those endpoints where the message should be published. This means when a message is published to a topic, the message will be sent to all subscriptions of that topic. If the subscriber's endpoint doesn't acknowledge the receipt of the message, the notification service could retry that delivery. As an example, when you are sending the notification message to an email address and let's say the mail server is down, the service could retry that delivery again. Notifications are integrated with other OCI services like the monitoring service, where you can configure the alarm to send the alarm messages to topic subscriptions. So the first configuration step in notification is to create a topic with one or more subscriptions. You can use the OCI console or command line interface, APIs or SDKs to create topics and subscriptions. These are some of the subscription types that you can use. The email, which is for sending an email to one or more email addresses each time the alarm state is changed. You can choose OCI functions to run a specified function. HTTPS, let's say you have a custom URL where you wanted to send the alarm message to that custom URL. PagerDuty is another subscription endpoint. You can choose PagerDuty that allows to create a PagerDuty incident when receiving alarms. A Slack subscription can also be configured to send the message to a specified Slack channel. And then finally, the SMS subscription for sending SMS text messages. To wrap up, we had an overview of the notification service. We learned about the concept of topics and subscriptions. So that's all in here. Thank you for watching. Hello and welcome to this demo. Here we are going to configure the notification service with creating a topic and a subscription. I've now logged into the OCI console here. So the very first step, navigate to the region. I'm using Australia Southeast Melbourne, and then click on the top left burger icon. Notification service can be found under developer services, and under application integration, click on notifications. Let's change the compartment. I have few topics that I've already created, but let's proceed to create a new topic. Let's name it as demo. I've created the demo topic here, and let's click on the topic that we created here. And within this topic, you need to add subscription. So let's proceed to create a subscription. And here we're going to choose the email subscription. There are different endpoints that you can choose from: email, functions, custom HTTPS, custom URL, PagerDuty, Slack, and SMS text messages. So here we are going to choose the email subscription, and then we need to specify the email address. So I'm just putting my personal email here. The status of that subscription that we created shows as pending because we need to go into that email. We would be receiving an email to confirm that subscription. So let's go to that email, confirm it, and come back to this page. Here is the email that I received. So let's proceed to confirm. And now let's navigate back to the notifications service and see the status of the subscription. The status have now changed from pending to active. We'll be using this topic in our monitoring demos. So that's all in here. Thank you for watching. Welcome back. We are going to look at the concept of alarms and some of the best practices of defining alarms. The alarm feature of monitoring service enables you to send alerts when there are specific issues or values that fail the threshold condition. The diagram here shows an illustration of the alarms workflow, each resources that are emitting metrics into the monitoring service. In the next step, the metric data is aggregated based on the functions that we apply. For each metric, you would then define alarms and using a trigger rule condition. Remember, to create an alarm, you would need to specify a metric, a statistic, an interval, and a trigger condition with a comparison operator. If the alarm specified trigger is not met, the status of the alarm would be OK. Once the trigger condition is met, the alarm changes from the OK state to the firing state. One of the configuration steps with defining an alarm is the integration with the notification service. We will see some of the best practices of setting up alarms in the environment. The first recommendation is to create alarms for each metric based on resource behavior. Like for those resources at risk, you need to create alarms for metric values that indicate the resources could eventually become not functional. Giving an example, we usually refer to the utilization metric that is greater than 80%, and a compute instance breaching that threshold could be referred at risk, and it can potentially fail. We would also need to create alarms for those resources that can become non-optimal. Here, the threshold for that metric would be between 60 to 80%, and when the metric value is within this range, the instance can be considered as above the optimal operational range. And then you would also need to create alarms when the resource is up or down. The next best practice is to choose the correct alarm interval for metrics. This would depend on the frequency at which the metric is emitted. Let's say a metric that is emitted every 5 minutes would require a 5-minute or a higher alarm interval. In the monitoring service, most metrics are emitted every single minute, and that means most metrics can support any alarm interval. The next best practice is to suppress alarms during mitigations or while you're investigating the issue. This would help you to avoid distractions and also need to ensure that you remove the suppression when the issue is resolved. It is highly important to run routine checks and fine-tune those configured alarms because the environment is always dynamic with frequent changes happening to the environment. You would start with looking into the criticality of each resource and see if there are any changes. You would also need to assess the resource behavior and review any fluctuations with those metric values being reported. And then finally, assess the notifications method and making sure you have added the correct recipients along with the frequency of repeated notifications. To wrap up this lesson, we saw the workflow of alarms feature, how it is integrated with the monitoring service. We also referred to some of the best practices in defining alarms. So that's all in here. Thank you for watching.
Welcome to this demo on service metrics and alarms of monitoring service. I have logged into the monitoring service through the OCI console. There are a wide range of service metrics that you can access through the monitoring service. For example, with choosing the metric namespace, OCI block store is for all the metrics for the block volumes. You can monitor the different metrics for volume read and write throughput, the volume read write operations, the throttle operations, etc. There are other metrics that you can access through this namespace. We are not going to cover each metric by metric, but just to give a conceptual overview of each metric namespace that you can use to monitor based on your requirements. You have also got the OCI object storage, which is for your object storage buckets. You need to specify at least one dimension to see object storage metrics. So let's try to quickly select one of the dimension. We will select the resource display name and the name of the bucket. There are primarily two metrics that you can monitor here. The size of the bucket, which is in bytes, and also the number of objects that are uploaded to the bucket. There are metric namespaces for compute and VCN. In particular, we are going to look at the OCI compute agent again. These metrics are emitted using the compute agent, which is running on compute instances. The plugin should be enabled by default, but let's take a look on how to see or access that plugin through the compute instance UI. And for example, I'm selecting one of the instance, which is a Windows server, and you can see the tab called Oracle Cloud Agent. And this tab manages all the plugins that are running within this instance. Scrolling down, you can see the different plugins that are running in the instance. And for example, in our case, we have the compute instance monitoring plugin is in running status, and the plugin has been enabled. So that means we are collecting metrics like those CPU utilization or memory utilization through this plugin. So let's navigate back to the monitoring service. And we are going to create an alarm for the CPU utilization and defining a threshold to trigger an alarm. So let's click on the alarm definitions here and click on create alarm. Let's name the alarm with CPU usage. The severity is critical. Let's just enter a custom alarm body. We will leave the tags as optional field. Under the metric description, you would need to choose the metric namespace, which is the OCI compute agent, and the metric name, which is CPU utilization. We want to look for the CPU utilization every 1 minute, so I'll leave it as 1 minute. The statistic is, again, we're going to choose max. You could add a metric dimension with for the specific resource, but let's leave it blank for now. The trigger rule is the operator that we are using is greater than, and the value that we want to provide is, let's say, 50%. And let's leave the trigger delay minutes is 1 minute, which means it's going to check the condition for that 1 minute. So under the notifications, the destination service is notification service. We are choosing the compartment where we wanted to send notifications. The notification service use a concept called topic, and it is a communication channel. So we also have an option to create a topic, but in this case, let's use an existing topic. And this topic has a subscription with an email address. And when the alarm trigger condition is met, it should send an email to the subscribed email address. You could use the message format to send formatted messages. I will leave that selection as default. We are not going to select repeat notification, but if you select repeat notification, you can specify the notification frequency. 60 minutes here means the notification will be repeated after 60 minutes if the alarm is continuing to be firing. So let's disable repeat notification for now. And last step is to enable this alarm, and let's save the alarm. So we have now created the alarm, and you can see the status of that alarm is okay, which means we don't have any of the instances reporting CPU utilization greater than 50%. So I have a Windows Server instance which I have logged in using the remote desktop. I have downloaded a CPU stress tool. Before we run, we will look into the task manager and see the CPU utilization of the instance. So we can see it is just 2%. So let's try to start the stress. These are different threads you can add or activate with clicking on the activate threads. And then you can see the CPU utilization have jumped into 30%. Let's start another thread. It has getting increased by 10%. We will start one more thread. We can also add a few more threads here. So right now the CPU utilization is running at 84, 85%. So let's go back to the OCI monitoring service and see the status of that alarm definition that we have created now. Let's take a look into the service metrics page and see how the CPU utilization is looking like. So choosing the namespace again as compute agent. And you can already see the graph for CPU utilization. There is a spike here, but just to make it more specific, let's add a dimension value with the name of the host, which is Windows Server. And And you can see the percentage has been over 80%, as you can see in the graph. And so this should actually trigger an alarm. So let's go to the alarm definitions here and click on the CPU usage. And you can see the alarm status have been changed to firing. And this means you would also get a notification on your email you subscribed within the topic. So let's log into the email address and have a look at the email that we received for this alarm. So I have just logged into the email address that I have subscribed. So you could see the CPU usage alarm has sent a notification with the severity, the status is firing, the query that we created for CPU utilization for every 1 minute with a max value greater than 50. So that concludes this demo. We looked into some of the service metrics and also creating alarm for one of the CPU utilization metric. We will now look into metric queries and see how to write and build queries using the advanced mode of Metric Explorer. Thank you for watching.
Welcome back to this lesson on access and limits of monitoring service. We'll be looking at how to access the monitoring service, including the IAM policies and some of the limits that you should know in regards to the service. There are different ways you can access the monitoring service. You can use the OCI console and navigate through the observability and management section, or you could use APIs or SDKs or CLIs. Metric Explorer is a UI section of the monitoring service, and this is where you can write or build queries. There are two modes of this Explorer, the basic mode and the advanced mode. The basic mode is more sort of a UI-driven approach for building queries, and the advanced mode is more of writing queries using the monitoring query language expressions. These are some of the examples on accessing the monitoring resources using the CLI. The CLI for monitoring starts with OCI monitoring and then followed by the resource type in execution. And here in this example, OCI monitoring metric list with specifying the compartment's OCID would return all the metric definitions in that compartment. The same way OCI monitoring alarm list with the compartment's OCID will show all the alarms configured. To publish custom metric data points into the service, you would use OCI monitoring metric data post followed by the configuration parameters. To create an alarm, we would use OCI monitoring alarm create and then followed by the options. To delete a suspended alarm, you can run OCI monitoring suppression remove followed by the alarm's OCID. The service is integrated with IAM, Identity Access Management, for authentication and authorization. You would create IAM policies depending on your organization and access requirements, and these are a few examples here. You have created a group called Alarm Viewers. Typically, they are like Network Operations Center, who are the first level operations who get notified for alarms. In most cases, you would assign these two policies for the group so that they could just see the alarms and retrieve metrics. Looking at the policy, allow group alarm viewers to read alarms in tenancy. Every IAM policy starts with the allow statement. And then we define the group, which is the name of the group. Here we have alarm viewers. And then we use the verb read, and we are applying this policy across the tenancy. So this is a tenancy-wide rule, and it gives permissions to all users in the alarm viewers group to view alarms across the tenancy. The second rule is allow group alarm viewers to read metrics in tenancy. This is the permission to view and retrieve metrics at the tenancy level. You might also have a group assigned to create and manage these alarms. Here we have created an IAM group called Alarm Admins, and a policy is assigned to that group. We are using the verb manage. That means it would include all the permissions for that resource. The policy would be allow group alarm admins to manage alarms in tenancy. To provide access to read and retrieve metrics, we would use this policy, allow group alarm admins to read metrics in tenancy. And in the next policies, we are defining permissions to manage topics that are part of the notification service. So far, all the policies were assigned at the tenancy level. So if you have a group called metric readers and have them read and retrieve metrics only to a specific compartment, for example, a compartment with the name ABC, you would add this policy here, allow group metric readers to read metrics in compartment ABC. In some cases, you might also want a group with a very restricted view to metrics due to access to confidential information. So in that case, we would use the verb inspect, and the policy would be allow group metric viewers to inspect metrics in compartment ABC. In the next example, we have a group called metric developers, and they are assigned to create metric definitions that would also include the ability to read and publish custom metrics. So the policy here, allow group metric developers to use metrics in tenancy. The verb use is the next level permission to the read verb, and it gives the ability to update the resource depending on the condition. Now, one of the use cases of IAM policy is to reduce the scope of access to users and groups. These are some examples in context of limited scope of access. You may want to allow the group metric readers to read metric only at the compartment level, and then you are defining a condition. You are allowing that group to read metrics that belong only to the OCI compute agent namespace. The same way, to allow metric developers group to publish metrics with matching the namespace, we'll use the policy allow group metric developers to use metrics in tenancy where target metric namespace is equal to my custom namespace. Let's now see some of the limits of the monitoring service. Metric definitions are stored only up to 90 days, and then it will be deleted. The second storage limit, the alarm history, is stored only up to 90 days, and then it would be deleted. Most of the OCI services continuously emit metrics into the monitoring service, and there are no limitations on the amount of metrics that are posted by each OCI service. There are some dynamic limits to metric streams, and it depends on the query that you defined and also the number of streams to be aggregated. In some cases, depending on the query that you use, the maximum number of metric streams that you are trying to aggregate could be limited, and it can throw some exceptions that shows how many streams it can allow to aggregate. So what is the solution here? You would need to update the query to ensure the number of metric streams is within that reported limit. That concludes this lesson. To summarize, we learned the different ways how to access the monitoring service using the console, API SDKs, and we also saw a few CLI examples. We also learned about the IAM policies, how to have secure access to the service, and finally, the limits that you need to be aware of the service. So that's all in this lesson. Thank you for watching. Welcome back. We are going to learn about monitoring query language expressions, the components of queries, and also we will look into a few sample queries that you can use with the monitoring service. One of the key features of monitoring is that it allows you to create queries. We saw previously in our lesson there are two modes where you can create this query, the basic mode and the advanced mode. The advanced mode is where you can see the query in a monitoring query language expression. This expression would validate the data returned from raw data points. MQL or monitoring query language uses syntax, and this syntax would govern writing expressions that query the metrics. So an MQL expression is created with a set of components that are available through the advanced mode of the service. We saw the definitions of these components in our previous lesson, but just to recap here, the metric is defined as the measurement query for the resource, and that is part of the metric namespace. The interval, that is a time window used to convert a given set of raw data points. Dimensions is an optional component, and that can be used as a filter with providing name-value pairs. Grouping function is an optional component, and that is used for grouping or aggregations. Statistics is another aggregation function that is applied to raw data points. And then the comparison operators, that is also an optional component, which are used for defining alarms. Now let's look into the query syntax, and here are a few sample queries. The standard syntax of a query is starting with the metric, followed by the interval, and then the statistic. So how does this query look like? You can see the metric CPU utilization with an interval of 5 minutes, and using the statistic max to find the maximum reported value of CPU between every 5-minute interval of the specified time range. In the next query, we are introducing a dimension name and its value. So the query is metric followed by the interval, and then specifying the name of dimension with the value of that dimension, and then followed by the statistic. So taking from the previous example and then adding a dimension to it, we are looking at the maximum CPU utilization only for the Melbourne availability domain 1, and the value is collected between every 5-minute interval. In the third example, we are using the grouping function. The syntax is again same with starting the metric, the interval, and then we add the grouping function followed by the statistic. If we look at our first example, we will have multiple metric streams that represents each instances. And here with adding the grouping function, you're aggregating it to report the combined maximum value of all CPU utilization across all the instances. In the fourth example, you are using the group by function. The syntax is same as before, and here we are aggregating instances by the shape used by each instances and combining them together to report the maximum reported CPU utilization in each group. You can also create nested queries. That means you are creating a query inside of a query. We are also using a comparison operator to define an alarm. So here the syntax is the name of the metric, the interval, and the statistic, and then the comparison operator along with its value, and all this together becomes the first part of the query. And then we add a grouping function followed by the statistic together, forming the second part of the query. Looking into the example, the CPU utilization for every 5-minute interval, and looking for the maximum value reported on each interval. And then with the comparison operator greater than 80, we are specifying a condition to report utilization that are greater than 80%. The grouping function is used to aggregate metric streams. That means you are looking for the number of hosts with CPU utilization greater than 80%. And then in the last example, this is another nested query, and we are nesting a grouping function inside the query. We use a different metric here, the success rate, and the query is returning the number of availability domains with a success rate lower than 0.99. To summarize, we looked into building queries with MQL expressions, the different components of a monitoring query. We also referred to a few examples with using queries and also the nested queries. So that's all in here. Thank you for watching.
Welcome back to this demo. We are going to look at how to build queries using the basic mode and advanced mode of the monitoring service. So let's navigate to the Metric Explorer UI of the monitoring service. There are two modes where you can create metric queries. One is the basic mode, which is more UI driven. And the second option is you can use the advanced mode where you can write more complex queries. So let's start with creating a standard query. A standard query will have a metric, an interval, and a statistic. So let's choose a metric namespace We are going to use the same namespace, which is the compute agent, and using the same metric here, which is the CPU utilization. The purpose of using the same metric is to explain the concept of how to use the monitoring service and how to build queries. You could use any of these metric namespace and metric names for building queries, but just for this explanation, I'm using the compute agent and the CPU utilization metric. So I have selected the metric name here, and we will choose an interval of, let's say, 1 minute. A statistic could be mean, or we could choose, let's say, max, and click on update chart. So you can see the chart has been updated, and the most important thing here, you can see the query here, which starts with CPU utilization, which is the metric. 1 minute is the interval, and max is the statistic. So if you click on the checkbox to convert this basic mode to advanced mode, it has been provided with a query code editor. So you can add multiple functions to it. But in this case, it is a very standard query. So let's go back to the basic mode and try to update the query with adding a dimension. So with this query, we are looking at all the compute instances reporting the max value of CPU utilization. So you can see the graph representation here of different compute instances. So we will try to filter or add a dimension to see a specific instance. So let's scroll down, and under metric dimension, we will choose the resource display name, and the value is one of the instance we will be choosing, let's say the Windows Server. Click on update chart. So the chart has been updated, and what you're seeing here is just for that instance. And if you could see, the query also has been updated. Let's move to the advanced mode and take a look at the query. So earlier we had the CPU utilization, the interval, and then we are adding the dimension. The name of the dimension is resource display name, and it is equal to Windows Server followed by the statistic. Let's go back to the basic mode. Remove the dimension and click on update chart. The chart has been updated. So we have seen about metric streams. So we learned what are metric streams in our previous lesson. So to aggregate this metric stream, you can simply click on this checkbox and update chart, and it is going to aggregate all the streams into a single stream, reporting a combined utilization across all the instances. So this is also referred as the grouping function. The grouping function can be used through the basic mode. You could also use the advanced mode. So to show the grouping function using the advanced mode, let's uncheck the aggregate metric stream option here. Click on update chart. Let's navigate to the advanced mode. So we are going to add the grouping function. The syntax is starting with metric, then followed by the interval, and then we add the grouping function. So after you add the grouping function, it shows the different functions and statistics you can add. So let's choose max from the list. That's just duplicated, so let's remove this. Click on update chart. So you can see the metric streams have been aggregated, which means we are again grouping these streams into a single stream. And this is one type of grouping function. The next type of grouping function is called the group by function. We are grouping by different dimensions. We saw the different dimension names and dimension value. Let's see how to use the group by function. We just need to simply replace grouping by group by. We are going to group by the shape of each instance. And click on update chart. So you can see the graph is updated, but let's see what it represents, right? So you can see there are three different shapes that I have used when I created the instance. So I've used the VM standard E4 Flex, the VM standard E21, and the third one is the VM optimized 3 Flex. So the group by function is grouping by the shape that I used for instances and then aggregating the CPU utilization for each group. One another use case would be you can group by fault domain or availability domain. Let's say you have multiple availability domains and each domain having a set of instances. You can simply replace shape with availability domain and see the aggregated utilization for each domain. And the group by function is not supported in basic mode. So if you try to navigate back to the basic mode, it is going to throw a warning. So the group by function is not supported in basic mode, but the grouping function by itself is supported, where you aggregate multiple metric streams. So you would need to either discard the changes that you've written, or you need to make sure you are continuing to work using the advanced mode if you're using the group by function. So let's discard the query for now. We are now going to see a nested query. And with this query, we are going to look at the number of instances that are reporting greater than 50% of CPU utilization. So we could start creating a standard query using the basic mode, or we can write the query using the advanced mode. Let's try to add the query using the advanced mode. It is a nested query, so we start with the parenthesis. We have created the query, so let's click on Update Chart. We forgot to add a metric namespace, and that's why it is showing namespace cannot be null. So let's add a metric namespace and then click on Update Chart. So we started the query here, and you can see that there is one host that is reporting greater than 50% CPU utilization. So that's all in this demo. We saw how to create metric queries using the basic mode and the advanced mode of Metric Explorer. Thank you for watching.
Hello and welcome to this lesson on OCI logging service. We'll go through a quick overview about the service, the different types of logs that you can ingest into the service. And also, we'll look into an end-to-end workflow of different stages involved during the log transition process. Logging service is defined as a highly scalable, fully managed single pane of glass for all types of logs from your environment. These could be logs from your OCI services, or it could be external logs outside of Oracle Cloud Infrastructure. And that makes logging a centralized and secure log management service for all logs for your environment. The service is highly interoperable, and it is built on open standards that use the Fluentd agent for log ingestions, and it is compliant with CNCF Cloud Native Computing Foundation cloud events. There are different ways to use the service. You can use the OCI console, CLI, SDK, or REST APIs. One of the core features of the service is to create rule-based actions on log events. This is done through a service called Connector Hub. We'll be covering a few scenarios later in this module. Logs are encrypted in flight. That means they are encrypted during the ingestion process. After the logs are in the system, they are encrypted with disk-level encryption, and then the logs are also encrypted when they are archived and stored within the storage. Logs are classified into three different types within the logging service. The first one is called the service logs. These are emitted by the OCI native services like the VCN, Virtual Cloud Network, or Object Storage, Oracle Functions, etc. There are predefined logging categories for each OCI service, and you can simply enable or disable using a single-click approach. We'll be seeing how to enable service log in one of our demo. The second type of logs are called custom logs. These are logs emitted by custom applications on OCI, or it could be a workload running outside of OCI environment, like the on-premises or an external cloud provider. There are two ways you can ingest custom logs, one by using an API or using the Unified Monitoring Agent. You can also refer to this agent as the Fluentd agent based on CNCF standards. The third type of logs are called audit logs. These are events recorded for API calls executed to all API endpoints of OCI. As an example, when you're uploading an object into the object storage bucket, it runs an API call to the backend API endpoint. These events are available out of box through the audit section of logging service. That means you don't have to configure anything to access the audit log events in the console. Let's look into an end-to-end workflow of the service. The first stage is where you collect and manage logs. You would configure the OCI services and resources to collect logs. This would include service logs, audit logs, and custom logs. Let's say you have an on-premises environment and you wanted to collect application level or security level logs. The next stage is where you define your search criteria. You may want to look for specific log data or maybe some keywords within the log data. You would create logging queries to filter this data. And at the next step, and once you have filtered the log data, you wanted to take an action on this data set. For example, if there is a specific error pattern seen in the log, and you wanted to execute an Oracle function to remediate that problem. Another use case would be there is a requirement to archive those legacy logs into the object storage bucket, or maybe writing them into the OCI streaming service. These actions are executed through a service called OCI Connector Hub. And we'll be looking into the connectors, the Connector Hub, in a later lesson. To summarize, we looked into an overview of the OCI logging service, the different types of logs, and also an end-to-end workflow of the service. So that's all to get started. We will now focus on some of the specific features and learn more about the service. Thank you for watching. Welcome.